All right, we're going to go ahead and get started. Just a quick note for all of my friends on the live stream at home. I'm going to pop into the Discord channel after this talk and answer some questions there. So if you're not part of the Discord channel yet, there's a join the discussion link on the right side. Go ahead and pop in there and ask some questions, and I'll see if I can't get them answered. So this is, does your API need a REST? Check out GraphQL. My name is Dan Vega, Spring Developer Advocate at Broadcom. I'll tell you a little bit about me in a second. My objective with this talk is to inform you about what GraphQL is, and more importantly, when you might want to reach for it. And then we'll walk through some of the mechanics of kind of building out a GraphQL API in Java and Spring. So quick show of hands, how many people are building REST APIs today? Should see all the hands, most of them. How many people are building GraphQL APIs today? All right, perfect. This is a good audience. So we have a bunch of code that we'll go through today. If you want to get it later, you can go ahead and check this out on my GitHub, github.com/danvega/GraphQL store. There's a main branch, there's a start branch. We're going to go through a couple things with that. So I'm just giving a second to get that, take all the pics, check it out of it. Okay, a little bit about me. Again, I said my name is Dan Vega. You can learn a little bit more about me at danvega.dev. I'm a husband and a father. It's my beautiful wife, Jen, our two daughters, Isabella and Juliana. We live outside of Cleveland. I was named a Java champion this year, which was one of those like lifelong career goals. So I was really excited about that. I put this number up here, 23 years. I hate putting that number up here because it makes me feel old. I've been doing this a while. I've worn a lot of hats in this industry. My favorite hat that is the one I'm currently wearing, which is a Spring Developer Advocate. But long before someone was paying me to do so, I was a Spring Developer Advocate. And one thing I like to share with everyone is that you do not need permission to advocate for the things that you're passionate about. So if there's things that you're using, there's things that you're passionate about, technology, code, whatever it is, go out and talk about it. Go out and write about it. Talk to your friends about it. Talk to coworkers about it. You don't need permission to do that, and you never know where it will lead. So I enjoy creating content. I'm still on the Bird app at the real Dan Vega. I don't know what we're calling it these days. I'm not calling it X. So, and when I'm not doing this, I enjoy running and golf. There's a show that we do called Spring Office Hours with my buddy Deshaun, who will be back here soon. But if you haven't had a chance to check this out, we live stream usually every Monday from 1 to 2 Eastern. And it's really a chance to get you caught up with everything that's happening in the Spring ecosystem, because there's a lot. We get to do this full time, and it's hard for us to keep up with everything that's going on. So we try to distill that down, let you know kind of what news is going on in the Spring ecosystem. So there's a live stream. You can catch the replay. We turn it into a podcast the next day. So if you want to catch us wherever you get your podcasts, that's a free resource. So a quick agenda. I want to start with why GraphQL, because I think it's very important to understand the why before learning a technology that you just heard on social media, right? Like, everybody's talking about this. I got to go learn it. Why do I need to learn it? So let's talk through that first. We'll talk about what GraphQL is, kind of a basic introduction to it. And then we'll move to Spring. Like, how do I get started with GraphQL in Spring? We're going to do some live coding. Hopefully that goes well. We'll have some fun with that. If I have some time, I won't probably get into too much of this, but I'll leave you with some slides. These slides for this presentation are in that repo that we showed earlier. So there are a bunch of other features that we're not going to be able to talk about today, but those are in the slides if you want to take a look at them. Okay, so Q&A. So why GraphQL? What problems are we trying to solve? REST is out there. That works. Seems to be okay. Again, your time and attention is valuable. Don't just learn something because somebody's talking about it. I think the first thing that you need to know is, like, why should I learn something? Also, don't get into resume-driven development. Just because you want to get a job and learn something new, why do we want to learn it? Because if you're in a job interview and you're asked about why do you use GraphQL, it's really important to understand kind of the why behind it. So here are a couple reasons for me. The first thing is no more overfetching of data, right? So when we talk about REST API, we have an endpoint. We go out and we ask the endpoint. Usually that endpoint's going to return all of the data that it needs to return. And this is regardless of what client is calling it. So we could have a desktop application that is calling this endpoint and has the real estate, has the bandwidth to show 40 fields of data, right? But then we can also have a mobile app that maybe only needs 4 or 5 of those fields. So why would we want to return that payload if we don't need all of that data? So for me, one is no more overfetching of data. Another one is multiple requests for multiple resources. So how many times have you been on a page somewhere and you needed a bunch of data? We'll see an example of this, but hey, I'm on a product page and I got to get the data for this product. Then I also need some related products to this product. So I make another call to another endpoint to get this. And this is probably on the lighter side of things, right? For many of you are out there where you're calling 5 or 6, 7, 10 microservices to get the data that you need on one single page, right? So being able to alleviate that, a single call, just get me all the data that I need. This kind of turns into that, avoiding the kind of explosion of API endpoints. So what I mean by this is we kind of all start off with good intentions, right? We create a REST API, things are going good, but then one of our other consumers or somebody inside our organization comes to us, says, hey, I like that endpoint, but I actually need another endpoint to give me the data in a little bit different shape, right? Or I need it to do this, or I need it to do that. And so we start taking these requests from all of our consumers, and we build all these different endpoints out. And so we know the more code that we're writing, the more code that we have to maintain, the harder that is going to be to keep up with everything. One of the things I love about GraphQL is we have this strongly typed schema. We don't get this in REST, right? It's just kind of an endpoint. In GraphQL, we have this strongly typed schema, which leads to a couple of things. One, we get some really great self-documentation out of this. And so that's important. How many people have worked on a REST API where you're just asked to call it and there's no documentation? Here, lots of hands going up. Here, because of the schema, we can basically hand someone that the endpoint for what we'll look at later, which is kind of the playground for testing these things out. And they can look at that and see the documentation and go, oh, I can get a list of products and that is going to return this. So this helps out a lot. Another thing that leads to this is a lot of really great developer tooling. And we'll look at a couple examples of this today. Who loves writing different versioning systems for REST APIs? I don't think anybody, right? This is one of the things that really kind of annoys me about REST is having to deal with all these different versionings. And it's just because of the way that we kind of change our REST API endpoints. When we get into GraphQL, we can kind of get away from this. And maybe we'll see some examples of that today. So that's the why. Let's talk about, a traditional REST API. We have a call to our REST API. This is an app written in Spring. Maybe we talk to a database and return some data. The way that we kind of break this REST API down is through many unique URLs, which are our fine-grained resources, right? So we may have an endpoint for products. We may have an endpoint for reviews and orders and customers. This is kind of how we think about building out our REST APIs. But again, that kind of leads to API explosion, right? Because we have these nice segmented URLs, these resources, but then we have some other consumers start coming to us. So now we have a mobile, we just started a mobile app and they're developing this app and they go, well, those API endpoints that you have are good, but we don't need all that data. We need an endpoint where it only returns this subset of data. Sometimes this leads to writing entirely new services, right? Like backend for a front end. So you have a completely new REST API just for the backend services. Maybe we have consumers of our API that are not within our organization. Now we need to tweak these a little because maybe we don't want to show sensitive data from inside of our organization. So we have a different set of APIs for them as well. In this example, I have this fictitious Waffle Corp company. You can think about IoT devices, right? That doesn't need 4 or 5, 40 fields. It probably needs 1 or 2. Hey, tell me when we're out of waffles and I'll order you some more. And the same thing with a smart fridge or something like that. So we have all these different consumers of our APIs and they all need different requirements, right? So what we can do is kind of flip this and say, okay, instead of us kind of defining all the requirements on the endpoints, we're going to give you a single endpoint. And that's going to be it's usually a post request @/GraphQL. And now you get to tell us what you want. So I need these 3 fields, or I need the graph of data that goes all the way down. I need this much information. So again, we talked about this example earlier, but traditionally in a REST API, I would say, hey, give me the data for product 1, 2, 3. Then give me all the related products for that product. then go ahead and give me all the reviews for this product. So now we're calling out 3 times. And again, the more this starts to build up, the more impact it's going to have on performance in our applications. And I know what you're saying. You're probably thinking, because I thought the same thing, why don't I just create an endpoint that kind of aggregates all of that data together and returns that to the client? But again, how many of these requests are you starting to get from consumers of your APIs? So again, we can just kind of create a single endpoint and they can graph that data all the way down. They could say, I want the ID and the title of the product. I want the related products. I want the reviews. And these are the fields on those kind of subgraphs that I want. So as long as we're talking about REST versus GraphQL, I kind of want to get something out there. There's some myths about GraphQL that it's complicated. And I want to talk about that for a second, because for me, REST is pretty complicated. It's just what we know. It's what we've been doing forever. But if you think about REST, if you took somebody who's never written a REST API and you threw them in there and you said, here are the different components of a REST API, you need to understand these things called HTTP verbs, right? Like, is this a GET request? Is this a POST request? There's a whole bunch of status codes. I know there's a top level layer of some of these, right? But here are all the status codes that you got to worry about. Then we kind of break things down into different resources and different paths. API version. Not a lot of fun to do to maintain different versions of a REST API. And, we got to write documentation for this. Now, I know there's some tools out there that help with this, but these are things that we have to think about. And again, when it comes to GraphQL, it's not complicated. It's just something new. And with REST, it's something that we've just been doing for a while. And so I think that we're just kind of used to it. So that's my why. Some reasons why you want to learn GraphQL. Let's talk about what it is. It's an alternative to building APIs with REST, right? It starts with graph. It's graphs all the way down. We get to model our business domain objects as like a graph all the way down. QL stands for query language. It's a way for us to kind of access this data. And this really started because of some of the problems that we just talked about, right? So Facebook kind of started this because as the mobile scene kind of came into play, we talked about that. We have all these different services. And on a desktop, I can probably call these services, and these extra requests and all this extra data may not be as big of a deal if I have the bandwidth, if I have the processing power. But on a mobile device, I may not need to, I may not have all of those for me. So they kind of started the idea of GraphQL. These days, it's governed by a foundation, so they don't own it. So if you want to learn more about a lot of the different companies that are involved with GraphQL, you can do it at graphql.org/foundation. And yeah, that's really great. So one of the questions I get often is, okay, how do I get data out of GraphQL? And I want us to kind of not think about that right now. The same way that we don't with REST, right? So GraphQL is not tied to any specific database or storage engine. Instead, it's kind of backed by your own data. And what I mean by that is you don't ask that in REST. In REST, you have an API, you have an endpoint. You're usually delegating to something else to get you data, right? Whether it be a cache or a database or another microservice. And it's the same with GraphQL, where we have in Spring, we have a controller that takes in a request. We'll delegate that to something else. So there's a client and a server, 2 sides of this, right? If you want to read about the spec, if you're really into reading specs, you can go through and read this. I don't know. I read a little of it. It's interesting, but if you have some time and you want to go through it, you can. The thing about the spec is that I really enjoy is because there's a spec, there's implementations in different languages, right? So if you are using this in Java and then you get put on a project in JavaScript, most of the things should seem pretty familiar to you. You don't have to, it's not the wild, wild west, right? So that is one of the great things about spec, and that's what I really enjoy. There's great support for this on the JVM, as we'll see. One of the first things that you'll see in that spec is about the type system. Again, this is something you don't get in REST. So the type system is how we're going to define our schema. The first thing that we start with are object types. And this is the most basic component of a GraphQL schema. And it really just represents a kind of object that you fetch from your service, what fields it has, and so on. So here we define a type. We're calling this product. On the left are fields. So we have fields called ID, title, and description. On the right is the return type. You also see an exclamation point that says, hey, this is not nullable. That means you never have to worry about a null case. You don't have to do catches for that. That's not going to be null. And again, what's on the right are types. There are some built-in scalar types. There's only 5, which is nice. There's extra if you need them. We'll talk about that in a second. But there's a very simple type system, so it's easy to get up and running. You can also reference other object types. And then we have support for things like custom scalar types. So if you need like a date or a date time or a UUID, you can get those from some of the different libraries out there. There's also enums, interfaces. We'll see a union today, which Java doesn't have. So we'll see examples of that. So these are the basic scalar types. This is awesome because you don't have to learn a lot of different types. Int, float, string, boolean, and ID. ID is representing something unique in the system. So we have those object types. The next thing we need to know is operation types. So we have our GraphQL schema. We have our object types on there. And then there are 3 operation types: query, mutation, and subscription. So query is, hey, I want to read some information from the schema. I want to get a product, or I want to get a list of products. A mutation is, I want to change it. I want to update, delete, create, right? A subscription, similar to query, but I want to open up a connection and leave it open. Think like your traditional stock ticker example. So how do we define an operation type? So we have our type product here. Again, we say type query, so that's the operation type. What's on the left is the field. What's on the right is the return type. The little brackets here are denoting that this is a collection. It can be 0 or more. And then we can also do things like pass arguments in. Here's where we can really start to like build out a graph. So I can get a product may return like an order, etc. So we can start to graph this out. So with just the object type and the operation type, those are really kind of the basic building blocks of a schema. Again, we can define things like enums. We're used to enums, right? So I could say, hey, order status has to be one of these values. I can use things like interfaces. So I can say, here's a review. It has ID, title, body, and rating. But I'm going to have 2 interfaces here that implement that. And it just needs to contain those fields, and it may define other fields for itself. What we don't have in Java is something called a union. We'll see an example of this today. So union search item could be one or the other. So I'm saying, hey, I'm going to search for some string. I may find a product. I may find a customer. I don't know which one it is. So we have those 2 object types there. And then we can do something on that, like when we make our query, to say if it returns a product, here's the fields that I want. If it returns a customer, here's the fields that I want. Again, arguments allow us to kind of build out these graphs. So we have some arguments here, and we can also say, are these things required? So you cannot call me without an actual ID. It cannot be null. I need a value here. Now, it's not to say that we don't get a product that doesn't exist in a database or something, but you have to pass one of those into. And then we have some, so the other thing is, in a system like REST, you can really only pass a single set of parameters, right? The query parameters and the URL segments. But in GraphQL, every field is a nested object and can have its own set of arguments, making GraphQL really a complete replacement for making all of those multiple requests that we talked about earlier. So one more thing I want to talk about, actually a couple, but the output types that we defined earlier, like product. Product, any object type is what's also known as an output type. So here's an example of, I want to create a new product. So this is a mutation. Remember, query, mutation, subscription. And I take in some fields here. I take in a title, I take in a description, and I return a product. And you might think, okay, well, if I had a few more of those fields that were arguments, I might want to create a type. I don't want to have 5 fields, get 5 arguments passed into this. So you might think, well, let me just pass in a product, right? Because I have something that looks like that. But again, object types are output types. If you want to use it as an input, as an argument, then you need to create an input type. So we have, to create an input type, you just use the keyword input and say, here is my product input. And this is similar in the Java world, right? We create DTOs for things like this. So just remember, if you need an input type, use the input keyword. And then variables. So here's a query. We're actually gonna go through GraphQL, which is this nice playground to kind of test some of this out. But if you pass in like values like this, like the ID is 99, first is 5, in the GraphQL UI, you can actually define variables by using that like $sign and then the name of the variable. We'll see an example of that. So one more thing I want to talk about that's defined in that spec that I didn't read all of is how to handle errors. And this is something we have to talk about because every time I talk about this, people's minds are blown because, again, try to get out of like, hey, I've been doing REST all my life. This is what I know before we move on. But all right, let's say we had an example where we asked for a product with an ID of 99. This is going to return a 200 status, not a 404. And I know we're all used, again, we're used to like, hey, if I make a call, I want a status code to tell me exactly what's going on. And this might throw you off at first. But again, because we have a graph of data all the way down, what if I asked for an ID of 99 and that did bring me a product back? But then I asked for an order with an ID of 99. If we just returned 404 for that whole thing, that wouldn't make a lot of sense, right? We're returning parts of the graph that are available. Parts of the graph that are not available, you will get an error for, and you'll get them, that error is part of the spec. That's how they're returned. So in that case, the data is going to come back in the data key, and the errors will come back in the error. Again, I think it's just what we used to, and when we see that, we kind of have this reaction, right? So with that, I want to jump into a demo. Let's see if we can do this. So I have an application running. This is that repo that I showed you before. This is the main branch. If you run this, as long as you have Docker installed, it kicks up a database. So it's using Docker Compose for this. But if you run this and you look at the resources and application.properties, one thing we define here is the graphical user interface. We turn that on. So this is disabled by default because we don't want you to like create this service, put it on a production, and anybody just be able to access this. So this is, I have to turn this on. Once I do that, I can come over to this interface, just make sure it's running. And this will allow me to, let me make this a little bigger. This will allow me to kind of explore the GraphQL API. I hate using it to test because it's not really testing, right? But if you've never written like a GraphQL query, this is a really good playground to kind of get started with this. Now, I love this for a bunch of reasons. One, we talked about documentation earlier, right? If I gave you some REST API, I remember being in different corporations and I don't know what to do here. What does this REST API do? I have to like call some other person, Slack them, get on a Zoom. How do I use this? Again, we have built-in documentation. So this Playground Explorer has the documentation right there. The first thing it defines is what are the operation types that are available in the schema. So we know we have queries and we have mutations. If I jump into query, I can see all the different queries that are available. So I can see that this one lists all the products in the system. We can also see that it has a return type of a collection of products. I don't know what is available in products, but I can click through and find out. So now I know that ID, title, description, and orders is available. So now what I can start to do is kind of play around with this. So now I can say query, and I can start to type. And one of the things you'll see is we get IntelliSense out of the box. Again, part of that strongly typed schema, we get some information. So I want to get a list of products that are in the system. But again, this isn't a select star. This isn't just give me everything. You have to be very specific with what data you want back. So I might say I want the ID, the title, and the description. So now once that is in play, I can go ahead and hit this button and I get the data back that's in the system. So we have a few different types of waffles that are available. So this is great. We're able to get all of our products. What if I just wanted the title? I can ask for that and just get that back. So again, I didn't have to create multiple endpoints to define the shape of that data. Now what if we wanted to get just a single product? So I see some IntelliSense here. And again, I get that for the fields as well, because those are on the schema. So for get product, we actually need an argument, right? We need to pass something in here. We get IntelliSense for that. We can say I want the first one. And what I want back is, I don't need the ID because I already passed it to you. So I'll just ask for the title and the description. And so we get that back. So these were some basic queries. One of the ones I talked to you about earlier was the union. That can be a little bit complex to write if you haven't written GraphQL before. But the graphical user playground here will assist us in that. So there's this little GraphQL Explorer, and I see all the queries here. So I don't even need to type these out if I don't want to. So I have that search, and that search is, I'm going to search for a string. It's either going to bring back a product or a customer. So I can go ahead and click on this. All right, good start. So I'm going to provide some text. So let's provide the text Dan. And I might bring back a product. I don't think we have any products named Dan, but let's just be safe. And it might bring back a customer. If it brings back a product, I want the ID, the description, and the title. If it brings back a customer, I want the first name, the last name, the email, and the ID. So now you can see it's kind of assisted me with that. And this is that syntax that you need, this ... on, if you have a union that comes back and it might return one or more types. So now I can go ahead and do this search, and we get back a customer. We can see that because of the data that's coming back, the fields. So again, strongly typed schema, documentation, developer tooling, a lot of the reasons that I really gravitate towards GraphQL. Okay, let's go back to a few more slides, and then we'll do some live coding. All right, so how do we get started with GraphQL on Spring? First off, you should know it's really a collaboration between two projects, GraphQL Java and Spring for GraphQL. GraphQL Java is the implementation of the GraphQL spec. We talked about that spec. There are a couple different Java libraries out there that implement it. This one's probably the longest standing one. So we talked about Facebook open sourcing this back in 2015. This started in mid-2015, and it was started by Andy Mark, who is a software architect at Atlassian. There's a really good episode of the Beautiful podcast with my coworker Josh Long, where he interviewed Andy about starting this project and kind of the motivation behind it. So if that's any interest to you, I would go ahead and check that out. The thing to know about GraphQL Java is, for me, software projects, like, they do one thing really well, right? They're not trying to do everything. And that's what this does. This is a pure execution engine of those queries that we're writing, but it doesn't provide any transport layer. There's no HTTP, there's no IO. It's just kind of that execution engine. Very active on GitHub. This is what adds those custom scalar types. So because we have GraphQL Java, if we need to define a custom type like a date or a date time, we get those available to us. You can learn more about it at graphql-java.com. There's also a really good book written by Andy and his coworker, GraphQL with Java and Spring, if you're interested in checking that out. So again, GraphQL Java is a pure execution engine. When we write that query and we say find customer by last name, and here are all the things that we can kind of pull out of that. And here you can kind of see the graph layer, right? You can see the different subgraphs of this. What's underneath that query is what's known as a selection set. That selection set is handed to the execution engine, and that execution engine is what knows how to map it to different data fetchers in the system. So when you ask for an email, it knows how to go get that. What does Spring bring to the table? This provides support for Spring applications built on GraphQL Java. Again, I mentioned this is a really great collaboration between both teams. GraphQL Java is limited on purpose. We talked about that. We get that consistent, that familiar Spring programming model. There is a Spring Boot starter that you get with that you get a lot out of the box from. You don't have to manage what version of GraphQL Java we're using. There's testing support out of the box. There's support for different properties and configuration. So you get a lot from that Spring Boot starter. Here are some of the different versions. We're currently on 1.3.3, I believe. And this is a part of Spring Boot 3. You need JDK 17 at least, and this is built on GraphQL Java 22. Again, we saw this earlier, but now Spring kind of adds in that transport layer. So we can define HTTP. You can even use something like WebSocket or RSocket if you want to. And the way that we map this execution engine is through controllers. So we'll define a controller, we'll define some methods, we'll use some annotations to tie that schema to our code. All right, so let's have some fun and do a little live coding. So I am going to stop this. Let's stop. And hopefully nothing's changed. Yes, let's revert that. All right, I'm going to switch over to a start branch where I've kind of removed some code so we can write this together. And I'll just kind of walk you through it. So we have some different, oh, sorry. There we go. I have some different packages in here. So we're kind of taking a package by feature approach, and we have things like a product in here. So we just saw us kind of type out some of those queries. Those queries you'll see will map to some of these objects. So we have, in this case, we're using Spring Data JPA. Again, doesn't matter what your data layer is. You can use Spring Data JDBC. You can delegate to another service somewhere else. But I have a product here, and you can see that it has those fields that we looked at earlier: ID, title, and description. There's things for like orders and customers, reviews, that search that we did before. One of the things I want you to notice is the product controller is empty. So we're going to take a look at that and kind of fill in some of those details. But what I want to do is just go ahead and run this application and show you one of the first features of this. So there's a lot of logging in. I think I turned the JPA logging off for now. One of the things we have is this GraphQL schema inspection. So this is a way, as you're trying to write your schema and you're trying to line things up with your code, you can kind of find out where the missing link is. And so right away we see, okay, there's this query called all products, but I don't see a mapping for this. I don't have a data fetcher registered for this field. So you're going to have to resolve that somehow. So if we look at the schema, so this will reside in source main resources. This can be named anything. I just happen to name it schema, but it should end in GraphQL us. So if we look at this, this should start to look like things that we did earlier. I have these different queries. So one called all products, one called get product. We'll kind of focus on these for a second. Another thing I have is the Spring for GraphQL plugin for IntelliJ. This is going to give me some hints here. I have a controller mapping for this particular field somewhere. So I can actually jump from this to the controller where that is mapped. But as we saw in the schema mapping inspection report, I don't have these defined yet. So it's also telling me my IDE that something isn't lining up here. So we have things like mutations. Here's that union I defined. Here are those object types. This is kind of what the schema looks like. Again, not a lot involved in creating the schema. But I want to fix that first problem that we had, which was, hey, there's an all products query, but I don't have any data fetchers registered for this. So the way that we can do this is we can come into a controller, and this is where we are looking for those registrations, right? Because I have this mapped with the @controller annotation, we're going to start to look in here. So we have a couple of annotations you can use. One is schema mapping. If you use schema mapping, you have to define the type. So remember, there's query, mutation, subscription. I also have to define the field, which in this case is all products. And that would work. So now if I write some code here, when that field in the schema is invoked, this is the code that's going to get executed. But I can also shorten this down. So on top of schema mapping, as kind of the top level annotation, we have some sub annotations. So think of like request mapping has post mapping, get mapping, etc. We have something called a query mapping. So that eliminates the fact that you don't need to give it a type name anymore. Now you could still come in here and say all products, and that would be fine. But if you name this method the same name as the field is in our schema, then you can just use the query map annotation. So now I have this product repository. This is a Spring Data JPA, or Spring Data repository. In this case, I will be able to get, I have some list methods in here. So if I want to find all, I can get a list back. So I can delegate to that repository to get all of the products out of the database. So I'm going to say, I want to get a list of products back. Again, I want to name this the same name as the field name in the schema. So I'm going to say all products. And then I'm just going to use the product repositories find all method. Nope, find all. And now that should be it. So now if we were to rerun this application, and I will, and now we get this nice gutter icon, right? I can jump to the, I can jump to the schema. I can jump back and forth. So if I was here, I can jump there and jump back. So now if I'm in GraphQL, I have to reload this because we were using my main branch before. But now if I say query, now, no, that's not right. We should not, oh yeah, I guess we do have all those stuff. So now if I have all products and I can do the same thing I did before, which is ID, title, and description. And if I go ahead and run that, that works. What you will notice is get product. Maybe I didn't refresh this, but get product should not. I guess it's in the schema, so it should work. Okay, so now I want to implement the, hey, I just want to get a single product out of here. So again, we can use at query mapping. We can come in here and say this should return an optional of type product. And we will call this, so Copilot's here saying get product or product by ID, but again, I want to actually name it the same name as the field name in the schema. So I'll say get product, and then I need to map that GraphQL argument onto this controller argument. So I can use this at argument annotation. And again, if you look in the documentation, it says, hey, this is an annotation to bind that GraphQL argument onto a method parameter. So similar to like path variable, right? So I want to name this the same. So I'll say integer ID. And now what I can do is use that product repository to find by ID and pass the ID in. So if we were to run this again and go back to there, that should work as well. Now, one thing I want to talk about that we haven't talked about yet, let's go ahead and turn this on. So I want, where's my, yep, so here's, so I have some JPA show SQL currently turned off. I want to turn this on so we can see some of the SQL that's going on behind the scenes. So in my product right now, I have ID, title, description, and I also have something called orders. So in JPA, we've kind of mapped this using a one-to-many. So if I get a product, I want to get all the orders for that product. And if we go ahead and look at this, so get product, and let's say ID is 1, and what is going on? I want an ID, I want a title, and I want a description, and I want the orders. Now again, orders is another part of that graph. We can't just say, give me all the orders, right? I got to be specific. What is available to me? Maybe I even forgot what's in here. Let's go ahead and look at this. So if we go down to something like order, order has an ID, a product. Let's just say I want the quantity. We'll do ordered on and status, right? So when I do this, I want to go ahead and look at some of the queries that were run. So we can see underneath the hood here, we are selecting from product where P1 equals whatever ID, and then we're also getting the orders based on that particular product. But if I were to come over here and kind of get rid of this, right, and I run this again, you can see that we are selecting just from product. Again, because if we don't ask for that information in the request in the GraphQL schema, if we say we don't want orders, we're not being penalized for that being retrieved on the data side. But one more I kind of want to point out, what if orders didn't come from an association? So right now we have this association. What if I get rid of this? I'm going to have to get rid of the getters and setters, right? And what if maybe this came from a microservice somewhere else? Maybe we had some service to fetch orders. So what I can do to kind of resolve that, so we have a field named orders in there. So underneath the product, I can come in and I can use the schema mapping annotation. And I could say, I want to get a list of orders. I'm going to call that orders, because again, that's what it was named in the schema. And then I'm going to give it its parent. So if it's not clear, if we're under the schema here, product is the parent, the field is orders. So we will automatically pass that parent into the data fetcher. So now I can say, I'm going to get a parent passed to me. I can say product. And let's see, nope, that's not it. Find by product ID, product.getID. So now I can do that. And if I were to run that, instead of getting orders from the database, now it's calling this method, which is doing the same thing from the database, right? But maybe I have a microservice to fetch orders somewhere else. So now this code gets invoked. We maybe use like a REST client to call it to another service to go ahead and get the information for the orders. Now, there's one more problem with this, right? If we were to say, get all of the products and get all of the orders for every product, we're going to run into a little bit of a problem there. What's known as the kind of the N+1 problem, right? So if I make a request for a product, now I got to call this order service and get all the orders for just this product. Then when I get to the next product, I got to call that order service again and get all of those products. For this system, I only have like 4 products in here, not the biggest deal, right? But for a larger system where we're dealing with larger data, this becomes a problem. So there is an answer to that. We have this thing called a batch mapping. And so we can rework this to kind of do what is known as a batch. So we kind of collect all those IDs before we make that call, and we'll just make that call once and get all of that data back. So that's a good solution to that. Okay, we're getting up on it. I want to just talk about a couple other things really quick. And we'll take some questions. Oops, yep. Okay, so actually, I can't really go through all these. Some of the features that you can go ahead and click through on some of these slides. Sorry, that's better. There's really great built-in observability support. So again, one of the things with GraphQL that kind of lends itself to is being able to get information from different sources. You want to get it from a cache. You want to get it from a database. You want to call a microservice for something out. We can kind of build this graph where we get data from any point. Well, the problem with that then is you need some observability into that to figure out if things are going slow, where are they going slow? So with Spring Boot and Micrometer, you get some really great kind of observability into those interactions and where things might be kind of tripping. There's also built-in support for pagination. There is really great support for security right out of the box. Testing is one of those things, just like Spring. I love that you don't have to opt into testing with Spring. It's kind of there out of the box. Same with Spring for GraphQL. You get some really nice testing support right out of the box. I wanted to mention the DGS framework because our friend Paul here is sitting up front, and he has a session tomorrow on that. So if you want to see another great collaboration from the Spring team and Netflix, there's some really interesting things happening there. And I'll be there. I'll be checking that out. So I'm interested in seeing that. So if you want to, check out his session. There's a lot of more features, things that we don't have time to go through today. I just wanted to mention actually 2 others. One is support for federation. So this is new in, I believe, 1.3. So federation allows you, something Netflix does very well is kind of GraphQL APIs at scale, right? So maybe I have a single entry point for a GraphQL API, but I want to federate out to different services to kind of manage their own GraphQL APIs. So things, I have a product team, I have an orders team, I have a customers team. Those are all individual APIs, and we can handle that now with federation. That's a way to kind of fawn those out to different services. And there's also a really cool new feature with defer in GraphQL Java that if you haven't heard about that yet, I would say go read up on it. So that's it. Again, follow me on the Bird app at The Real Dan Vega. There's my email. You can learn more about me at danvega.dev. And with that, I'll take some questions. Thank you. I'm going to use this mic if you have questions. So anybody got questions? going, oh, I got one.
Question, what is the approach for versioning with GraphQL?
So again, with something like REST, you have to put versions on it because you have to be able to deprecate fields, right? With this, I showed you kind of that error schema before, right? So I'm going to return 200 every single time. I'm going to return a graph of data. So if you wanted to and you ask for a specific field, you could just deprecate that and have that as part of the information that returns back. You don't have to just go ahead and get rid of it, right? Or I mean, you can just go ahead and get rid of it. But you can't do that in REST, right? Because those kind of endpoints are hard-coded there. They exist, and that's why you have to version to have a different endpoint to support different data and different arguments.
But there's always a breaking point for something. Something will change at some point.
Yeah, something will always change. But because of that graph, you have a way to kind of evolve the API without breaking things, right? Like you're going to ask for something, you're not going to get it back, but you're also not breaking every endpoint or every consumer of that API, right? Anyone else? Oh. Don't ask me a tough one.
Can I ask you a question? I'm actually going to comment on that question. So because you have field selection, there's less of a reason to have to get rid of fields, but still sometimes you do. Because you have field selection and you know exactly what fields are there, you can actually track what fields are being used. So if you want to deprecate a field, you can actually get metrics on what fields are there, what fields are not, what your actual consumers are. You know exactly what's happening. So if you do want to deprecate a field, you know when can I safely remove it. Removal is still an issue. You are breaking consumers if you're not careful, but you kind of have better options than you had with REST.
Thank you. Appreciate that.
I see different set of mappings also has been written here. Like, for getting the products, I written some query mapping and then getting the product.
Mm-hmm.
Similar analogous to the same REST API. And for getting the list of all products, we have written one more method, list of products.
Yep.
So there were two different calls here. One for get, one for getting all the list of products.
Yes.
It would be the same even in the REST, right? For getting the products and getting all the products. Then how would I see the difference here? And one more thing is, as a developer, how would I really see the difference, whether my app is literally able to manage the bandwidth and able to manage the latency compared to REST API to GraphQL. Because if I want to compare the metrics, let's say I have a REST API application and it has multiple endpoints already.
Yep.
And in future, if I want to go with a GraphQL, assuming that Facebook kind of some mobile application, a new consumer is coming up and they want to invoke my REST APIs.
Yep.
And there is a sense that or a notion that bandwidth and latency may be a problem. Because of that, I may need to go to a GraphQL. How would I differentiate those metrics?
So that's a lot. Let me try and step back. On the one thing, so yes, you're going to have, if you have a call into a GraphQL API and that has some type of object graph, yes, you still may need to call a database to get one thing, and you may need to call a microservice to get another thing. But that's a single call into the API instead of 3 separate calls to the API. So you have that network latency that you're kind of getting rid of there, right? So that would be my first thing. As far as trying to figure out if that's a problem, that's a tough question. And that's really where observability comes into play. You have to have those metrics in place in your application, the insights as to like what is going on there. If you are a global company, again, I don't think we think about this a lot because we sit at home with, gigabit bandwidth. But there are a lot of people in the world that don't have that bandwidth. And so if you're a global company, that is something you need to think about, like where are people accessing our information from? And if they're coming from somewhere where there's not a lot of bandwidth, like we got to be mindful of that and not make them make 3 calls and not return 400 fields to satisfy some data endpoint, right? So I don't know about how I can answer that, but I think it really starts with observability and trying to find out what's going on there. And I was going to say, you may want to stay here because Jonathan knows a couple things about observability. So, yep. Can you pass it back? There's a little on switch on the back.
So you mentioned observability as a great factor to indicate whether the juice is worth the squeeze of tapping into GraphQL, of paying that time and cost factor of teams or an organization swapping over. What would you say are some other factors or key indicators to that a team of developers should be looking at to determine whether they should spend that effort to swap over to GraphQL? And then as a follow-up question, devil's advocate, why wouldn't you maybe want to swap over and stick with REST?
No, great question. So one, it wasn't like, is the juice worth the squeeze? It was when you get into developing GraphQL APIs, because you're building out this graph, I think you're pulling information from different resources. And when you start, I guess it's the same as a REST API though. We want that observability into where things are going wrong. But again, because I'm pulling from different resources, was it a problem fetching the product from the database? Or was it a problem spanning out to a microservice and grabbing all of those orders? Maybe we didn't know about the N+1 problem. Observability would tell me that right away, like, hey, you're for every single call, you're calling this order microservice 10 times. And so that really gives you that insight there. Again, the why, we talked about some of those at the beginning, the multiple fetches, the overfetching of data, API versioning, being able to get strongly typed documentation. For reasons not to move to GraphQL, I would say if you have a API in place already in REST, I wouldn't just rewrite it in GraphQL because you want to use GraphQL. I would say there's got to be some reasons there. So do you find yourself in the position that I was talking about earlier where you have all these consumers in your organization that keep coming to you and wanting you to rewrite endpoints to like match what they're trying to get? If that's you and you have a lot of different consumers of your endpoints, I think that's a great use case for that, because the less code we can write, the less code we have to maintain, the less error-prone code we put into production, right? So I think those are probably my big ones.
Awesome. Thank you.
Yeah, you're welcome. All right, I think we got to make way for Jonathan. So thank you guys so much.